In previous tutorial, I promised you I'm going to make for you the second part of the tutorial, that is binary subtraction using the ones complement and twos complement. You can also use direct method for subtraction of binary numbers, which is somewhat tedious because as the binary becomes big and big, it becomes more complex and hard to subtract. So that is why we opt to use ones complement and twos complement. As you can see here, you can just do some basic 3-bit, 2-bit subtraction directly, but when it becomes 5, 6-bit, 7-bit, it becomes more complicated to subtract using direct method. So the bigger the number, the hard it becomes when it comes in subtraction. So let us start one-on-one, or let us go one-on-one on subtraction using ones complement, because the ones the main aim, or the reason why ones complement is there, is to perform binary subtractions. That is its main agenda. Its main agenda is for subtraction, and we can see how it does the subtraction. So when you are doing subtraction using ones complement, you can proceed as follows. One, convert the number to be subtracted to its ones complement. Here we just assume that the numbers are in binary numbers, so convert the number to be subtracted into its ones complement. 2, that is step 1. Maybe you haven't understood step 1. We are saying convert the number to be subtracted into its ones complement. Here in its ones complement, as we learned above there, this means it's bitwise, not complement. It's bitwise, not complement. So the number, if for example we are subtracting, let's take example of a decimal like 5 minus 2. The 2 is the one which has to be converted to its bitwise complement. Hoping we are together. The 2 is the one which, not 5, the 2, 5 minus 2, the 2 is the one which has to be converted to its negative form, or its bitwise not part. The second step is you are supposed to perform addition. You add them. If, for example, take an example of a decimal, if it is 5 minus 2, it will be 5 plus minus 2. You add them. 5 plus the minus 2. The minus 2 is the bitwise complement of that binary. Step 3, if the final carry out number is 1, which is the overflow bit, if the final carry out number is 1, which is the overflow bit, the result is positive. If the final carry out number is 1, which is the overflow number or overflow bit, the result you have gotten there is positive. Add that one back to the result. We will see how that is done. Add back that one to the result. If the final carry is 0, then the result is negative. If the result is negative, the result you are going to get, you have to get the result's complement or bitwise complement of that result. If you get it as negative, for example, you get the final result after you have done the subtraction in ones complement, you get, for example, a result as 1 1 0 0, and the overflow was 0. The overflow bit was 0. You have to invert that number, or to get the bitwise complement of that number, which will be 0 0 1 1. 0011. You have to get the complement so that you get the correct answer. Let us see them by example. What do I mean by example now, so that you can understand what we mean? I have started with the first one, which you have to convert all these into binary. 5 minus 3, you have to convert 5 into binary and 3 into binary. In case you are given that, you have to convert both of them into binary numbers, because we are working with binary number. The second one is binary. You don't need to convert it again to binary, it is already in binary. Even the third one is binary, and you can see here I have already indicated for you that 1100 is equivalent to decimal 12, and 0101 is equivalent to a decimal number 5. Solution: let us solve that the three problems. Let us subtract them using the ones complement. What do? You have the first one, because the first one you have to convert it, all of it, you have to convert it into binary numbers, because it is in decimal numbers. You have to convert it into binary numbers. This is the 5 in binary number, the 5 in binary number, and this is the 3 in binary number, the 5 in binary number and the 3 in binary number. Now, up to this step, this and this, we already have our question like this one. We already have our question like this one. After we convert it to its binary equivalent, now our question has reached this point where this one is now. After that, we have to get the bitwise note of the number which was to be subtracted, and the number which was to be subtracted is 3. So we get the bitwise equivalent of these 3. 3 is this one in binary. You get the bitwise equivalent of this, which is this one. We saw that bitwise you have to negate all the bits. You have to negate all the bits. Zeros becomes ones and ones becomes zeros. That was previous tutorial. We saw that. So now we have our bitwise note of the number which has to be subtracted. So the 5 will remain being its binary in its binary form, and the 3 has to be converted to its bitwise note complement form. This is how I have written them for you. So that is 5, and this is the bitwise note of 3, which is the negative of 3. The bitwise note of 3, which is the negative of 3. Therefore, now, after you write it like that, you have to add them. Step 2 says you add the two numbers. You add 5 plus negative 3, which is the same as these ones. Now, you add this row to the row which is below here. How is it done? This is how we do it. We have done it before, so it is not something which is not familiar. We have done it in the previous tutorial. 1 plus 0 is 1. 0 plus 0, you get 0. 1 plus 1, you get 0, but you carry 1 to this column. So we have here 1 plus 0 plus 1, you get 0. Carry 1. 1 plus 0 plus 1, you get 0. You carry 1. 1 plus 0 plus 1, you get another 0. You carry 1 here. 1 plus that 0 plus 1, you get another 0. You carry 1. Plus 0 plus another 0, you get 0. You have a carry out number which is 1. Up to this point, you have a carry out number which is 1. So this is the one I'm talking about. This is the overflow bit. This one. This is the overflow bit, is also the carry out number. The one which is highlighted in red. The one which is highlighted in red is the carry out number, and it is also the overflow bit. 1 plus nothing. Obvious, we are going to get 1, which is overflow bit. Which is overflow bit. I can just highlight it for you to see. The highlighted one is the overflow number, or the overflow digit, or the overflow bit. What do we do with the overflow bit? Because that answer can't be correct, it is very wrong. That answer can't be correct, because if you add 5 plus negative 2, 5 plus negative 3, you are supposed to get 2. And if you convert this number here, it will never be 2. So how are we going to get 2? By adding this number, by adding this overflow back to the result together, by adding this overflow bit back to the result. So this is how it is done. This is how you are supposed to do it. You are supposed to add it back to the result like this. Let me show you how to do it. So this one should be added here. You add it there. So here, that is where I'm going to add it. You add it back to the result there. That one, I have carried it up to that point. So that one, which was this, I carried it up to here. So we don't have any more one here. We don't have any one, because the one which was here is brought here. I have to add it again, 1 back to the result. That is 1 plus 1. 1 plus 1. 1 plus 1 will give me 1 plus 1 will give me 0. Then 0, then 1, the carried 1 plus 0 will give me 1. 1 plus 0 is 1. The others, all of others, I'm sure you can see they will be zeros, because it is 0 plus nothing, 0 plus nothing, 0 plus nothing. All of them will be zeros. This was not correct answer, but when we carried the overflow bit and added it back to the result, we got now the correct answer. We got now the correct answer, because this one, you can see that one is 2 in binary, in decimal form, that is 2. So that is how you do it. And you are told, I told you that if the result has an overflow of 1, the result is positive. So you can see this is positive 2, which is a result of 5 plus minus 3, which is like 5 minus 3, you get 2. It is positive. If you have an overflow of 1, the result is positive. If the overflow is 0, then the result is negative. Let us see second example. Let us start just from there. 12 plus minus 5. 12 plus minus 5. That we can see we are supposed to get 7. So let us see if the binary which we are going to get is equivalent to 7. 0 plus and this one, make sure you write it in bitwise form. You can see from let us check above here, this was just 5. It was 5, binary of 5, but here I have written the bitwise, not complement of 5. Here it was 5 positive, but here I have written the bitwise not of 5, which is the negative of 5, which will be 1 0 1 0. From the previous tutorial we saw that how to convert or how to write in bitwise complement form. This is 0, we are adding 0 1 0 1 1, this is 0. So it means that we have an overflow of 1. We have an overflow of 1. The overflow of 1 plus nothing, it will give you 1. And let me highlight it for you to see that is an overflow. The overflow bit, we have to take the overflow bit and add it back to the result as per what we said. So I have to take that one and I have to add it back to the result. I have to add it back to the result, which is here. I have to add it there. So I say 1. Let us add again. This is the result. 0 plus 1. 1. 1 plus nothing. 1. 1 plus nothing. 1. 0 plus nothing. 0. 0 plus nothing. 0. You can confirm if this is equivalent of 7 or this is equivalent of 7 in binary, in decimal form. If this one is 7 in binary, in decimal form, if it is 7. Let us go to the other one, because now 12 plus minus 5, you are supposed to get 7. 12 minus 5, you are supposed to get 7. If you look at this one, which was the first answer, having an overflow, it cannot be 7. It can never be 7. You can also convert it and see what is this, but it can never be 7. The correct answer is this one, which you add back the overflow bit to the result. Then you get the correct answer, which should be 7. Let us go to the next one. Example 3. Example 3. So, example 3, we have 0101, which is equivalent to 5, and 0011, which is equivalent to negative of 12, meaning that the 12 itself is supposed to be 1100. This is the 12. This is supposed to be 12. It's supposed to be 12 from what we wrote above there. So that is negative 12. So we are adding 5 plus minus 12. 5 plus minus 12. Obvious, you know that here we are supposed to get a negative number, which is negative 7. We are adding 5 to the complement of 12, which is in its binary number is this one and this one. Let us go ahead and add 1 plus 1. 1 plus 1. This should give you a 0 and carry 1. 1 plus 0 plus 1, that is like 1 plus 1, which is 1, which is 0, sorry, which is 0. We carry out another 1. 1 plus 1 plus 0, it is like 1 plus 1, which is 0. Then we have 1 plus 0 plus 0, which is supposed to be 1. You can see the carry out here, or the overflow number, or the overflow bit is 0. The overflow bit is 0. 0, which is the overflow bit, plus nothing, you are supposed to get the overflow bit, which is 0. This 0 indicates that the result is negative. It indicates that the result is negative. So this 01000 is a negative number, and it is true, because when you take 5 minus 12 or 5 plus minus 12, you are supposed to get negative 7, and 0 here from 1's complement indicates that the result is negative. The result is negative. And which number is this? To know which number is this, let us get the bitwise not complement of this one, bitwise not complement of this number, because this number is negative. What was its positive number? What was its positive? Because now it is negative, like that it shows it's negative. What was its positive number? And its positive number, you can see, just neglect this one. you can neglect this one because it has no much meaning there. You can just neglect it and say the positive number of that one, because we saw this is negative, the overflow is 0, it is negative number. The positive part or the bitwise complement of that one should be 1 1 1 1 1 0 1 1 1 0, and this one was equivalent to 7. That one was equivalent to 7. Let us see, just because we have done it above here, let us see it. It's this one. 0 1 1 1, it is supposed to be 7. It is supposed to be 7. So here 0 1 1 1 is 7, and if you get the bitwise note of 7, you get this, meaning that this is negative 7, meaning that this is negative 7. So 1 0 0 0 0 is negative 7. If you get the bitwise note complement, you are going to get 0 1 1 1, which is 7. Part 3 and the last part is performing binary subtraction by using 2's complement. Performing binary subtraction by using 2's complement, like in 1's complement, the 2's complement of a number is obtained by negating the positive number to its negative counterpart. That is getting the bitwise note, which we talked about in the previous subtopic, which is 1's complement. The only difference is only adding 1 to the bitwise note complement before carrying out the subtraction. And another difference is here the overflow bit is neglected. It is not added back like the way we used to do in 1's complement. Here we just neglected it. It is neglected. It is not added back like the way we used to do in the 1's complement. Here we add 1 to the bitwise note complement before carrying out the subtraction. And another difference is that the overflow bit is neglected. In the previous subtopic, you saw that we were adding 1, or we were adding the overflow to the result, but here we don't do that. Here I also told you that is one of the disadvantage of using the 1's complement, but it is solved here in the 2's complement. It is being solved, or that issue is being handled here in the 2's complement. So let us tackle these examples. The first example is the one which we did in the 1's complement. We want to try it using the 2's complement, the part B and the part C. So the 5 minus 3 is the same as this one in binary numbers. It is the same as these ones in binary numbers. So we have to write bitwise note of the number which is subtracted. So we have to write the bitwise note of this number, which is 0 0 0 0 0 0 0 0 1 1. We have to write the bitwise note complement of that number, which is the bitwise note of that number is this one. That is negating, as we learned above from previous chapter, from previous subtopics. We learned that you have to negate. So I have done the negation of the number which has to be subtracted. So up to this bit, up to that point, we have learned it from the 1's complement. We learned up to that point in the 1's complement. To make this one to make this one work in 2's complement, because it is only the one which is going to be different. It's only one which is going to be different, or it is only one which is going to be altered again. To make it from 1's complement number to 2's complement number, this one, the one which is being subtracted, is the one which we change again from being 1's complement to 2's complement, because in this way it is in 1's complement number of this number. So make this one to be in 2's complement. How do you do that? You just add 1. This one, you just add 1. Here you add 2 zeros. Here you have 1 0 and then the added 1. You have 1 0 and the added 1. I hope now you can get what we are doing. You have the added 1 and the other numbers are the same, except the 1 0 which was replaced by that one which was added. Now this number is in 2's complement, while the first one, which is in bitwise not, is in bitwise not of 1's complement. How does it work? How does it work? Here you have added 1. Let us go and do the subtraction. Let's do the subtraction and see how does it work. This one is equivalent to 5. From the previous example, you saw that it was equivalent to 5, and it is equivalent. This is a binary number of 5. This one is the 2's complement number of -3. The 2's complement number of the 2's bitwise complement number of -3. Let us carry out the subtraction. Let us carry out the subtraction and see. So here you have 1. We are adding. We are even in 2's. We do the same as 1's. We add. We are adding the positive to the negative part. 1 plus 1, it will give you 1 plus 1 will give you 0, and you carry 1. 1 is carried here, so we have 1 plus 0 plus 0, which will give you the carried 1. 1 plus 1 will give you 0, and then you will carry 1. 1 plus 1, it will be 0. Carry 1 here. 1 plus 1, it will be again 0. Carry again 1. 1 plus 1 will be 0 again. It will be 0. So you have seen that one will be 0. This one will be 0. This one will also be 0 because of the 1 bit which is carried. Then we have the overflow again, which will be 1. You have the overflow, which will be 1. This is the overflow number, which is 1. So we said this number is neglected. That number is neglected. You are not supposed to add it back to the result as we did in previous 1's complement. So you can see this result is now correct. It's now correct according to our 1's complement. The result is correct even without adding back that 1. The result is correct. That is the advantage of using 2's complement, because you don't need to add that 1 back to the result. Example 2. Example 2 is the one which you added there. This is the 2's complement of -5. The 2's complement of -5, because up here, if we can just go back here and look at what we did in example 2, you'll find that example 2 add 1 0 1 0. This is the 1's complement. It had 1 0 1 0 as 1's complement. So to make it the 2's complement, we said that we are going to replace this 0 with 1, or we add 1 here, which will be 1 0 1 1. Let us see if it is like that. 1 0 1 1 1 0 1 1. That is the way it is supposed to be. Yes, that is the way it is. 1 0 1 1. This is the negative 5 in 2's complement. This binary number is the binary number which is in 2's complement, and the decimal equivalent is negative 5. 0 plus 1, it will give you 1. 0 plus 1, it will give you 1 again. 1 plus 0, it will give you 1 again. And 1 plus 1 will give you 0, and then there is a carryout number or overflow bit which is 1. We have overflow bit here which is 1, and this one we said we are supposed, if we are using 2's complement, we are supposed to neglect it, and this is like 7, so we got the correct result, that is like 7, and this is like 2. We got the correct answers there. You don't need to add that one back to the result. So homework for you, some job for you to do. Can you check if you can use 2's complement to calculate this one? Use 2's complement and see if it applies to the numbers which are negative, or the results which will be negative. The end result will be negative here. Check if it applies. Thank you for watching. Feel free to subscribe, like, and also share. Comment. If you have any question, comment it down there. I'm going to answer it. Thank you for watching. God bless you.